Hi, my name is Santiago Antañón, and today I want to talk to you about my latest project, which is called MDL. And MDL is a Z80 assembler optimizer, and I will tell you in a second what does that mean. So in this video, I just want to talk to you about what is MDL, what can it do for you, how can you use it, and a little bit of my future plans for MDL. All right, so let's just get started. So what is MDL? So MDL stands for minimum description length, and it is a program that can help you optimize your Z80 assembler code. So I called it MDL because, or minimum description length, because MDL is one of my favorite principles in machine learning and information theory, and in a way, my program MDL is trying to approximate, or it's very far from it, but at least trying to get to the MDL, to the minimum description length description of an assembler program, right? So it is an optimizer for Z80 assembler code, as I was saying. So what does that mean? It means that you're working in your game, your tool, your demo for whatever MSX, Spectrum, Amstrad. You're writing it in assembler. So you give it to MDL. MDL finds ways to make it faster and then tells these ways to you, right? So it can either tell you how to make it faster, or it can already modify your program automatically so that it's faster, right? So you can use it in very different ways. MDL is open source. You can find it in GitHub. I have been working on it for a couple of months, so it's still in early stages. Probably it's not very robust at this point, but you can already download it and use it. So why did I build MDL? Well, there's two main reasons. The first is we are all in this programming games business for MSX, Spectrum, Amstrad for different reasons. But for me, 95% of the fun is to make these programs or these games actually fit within the constraints of this hardware, right? Like most of the fun is to make my game fit in 32 kilobyte or in 48 kilobyte, right? I have a lot of fun making the program as small as possible so it actually fits. And can I fit as much information as I can? Can I figure out ways to compress it even more to add one extra enemy, one extra level, right? So that is 95% of the fun for me. So basically, it is a way to help using this limited hardware, right? Like limited CPU speed, limited amount of memory that we have. I know nowadays some people just like to use very large cartridges, like 2 megabyte, 4 megabyte, etc. But I mean, everyone enjoys this in a different way. I really enjoy like the challenge of compacting it into as little space as possible, right? So MDL is a tool to help you do that. Also to help you make your programs faster. So if you want to optimize for either speed or size, then that's what MDL can do. And the second reason is for fun. I thought it would be a fun project, right? To try to see if this type of optimizations that I spend so many hours doing, can I write a program that can do that for me automatically, right? And can it do it better than I can do it manually, right? The answer is no, of course. MDL cannot do it better than a human just yet, but it can definitely help, right? To make an assembler program run as fast as possible, you have to keep in mind lots of different details, and it is very easy to forget some, right? So MDL can help you with all of these things that you forget. There's always one thing that you forget here and there, and MDL can find those and actually help you make your code faster or smaller. All right. What can MDL do? So you can use MDL in lots of different ways. The three main ways in which I like to use it is first as a linter. So you can just bring MDL into your favorite IDE or text editor. I, for example, use Sublime Text, but you can bring MDL into many other editors. And just have it suggest optimizations directly on the IDE. You can also use it to automatically optimize code, like let it actually generate assembler code that you can then compile. Or you can also use it just to analyze your code, right? It can generate statistics and visualizations of your code that can help you optimize. So let me just show you very quickly how to use it as each one of these in these three ways. All right, so let me show you how to run MDL as a linter. I have here a folder with some of my MSX projects. So let's just try it, for example, in one of them. Let's try Xplunker. So I just open it with one of my favorite editors, in this case, Sublime Text. So I have here the project open. I can navigate to the source. So here is all of my assembler code. So I just go to the main file. You can assign any key that you want to MDL. In this case, I assigned Command B. So I press Command B. And now MDL is running. It just takes a couple of seconds. And once it's done, it says it has found 49 possible optimizations that save 49 bytes and 251 t-states. So for example, I could go through them here, or I could just click on one of them and see, okay. Oh, so this one is interesting. So for example, here in Xpelunker, I was loading a value into BC, a 16-bit value, but MDL has realized that just a couple of instructions below, I'm overwriting B, right? So it is useless to load this value into B. I should only load the value into C. So it has told me that if instead of loading this value into BC, I just load this value into C, I would save 1 byte and 3 t-states, right? And if you scroll up and down the code, in this case here, I don't see too many more optimizations. Oh, there's one right here. So for example, oh, here, this is an obvious one, right? So if you do a call immediately a ret, then it is better to just replace this call ret by just a jump, right? So there's collection of optimizations. So basically, this is the way MDL works when you use it as a linter. You just work in your code as you normally would, and every once in a while you call MDL, and it will point out if there's little things here and there that you can optimize. All right, so let me now show you how to use MDL to directly optimize code. So MDL is a command line tool. So it's written in Java, so I can just call it, I think I have it here in MDL.jar exactly. So you can just do java-jar and wherever it is that you have your jar. And without parameters, it will just print out this help screen, which is pretty long, sorry about that. But MDL has a lot of options, so it just shows you all of them. Let's say I want to optimize Xpelunker, the same as before. So the main file of Xpelunker is here in source Spelunk main asm. So I can just say source Spelunk main asm, right? And if I want to trigger the optimizer, I do -po. And if I just call it like that, it's gonna call the optimizer, print all the optimizations, and it has done nothing. It has just shown the optimizations to me, right? But if I want to actually generate code, I say -asm, and now say I want the optimized file just there. But I'm going to call it mdl.asm, right? Now it's going to do the same thing, except that now you will see that the new file will appear here that has, there you go. So this new file is already optimized, right? So this is the whole code of Xpelunker, all in a single file with all the optimizations applied, right? All in a single file, right? So for example, here, the main file of Xpelunker at the very beginning has these two includes. So the optimized file, instead of the includes, has the content of the includes there, right? So this is a single file that you can just compile and you will get your game already optimized. If you don't like that, right? So let's say that we don't like this. You can just, instead of doing that, you can say pure apply, right? And now it's going to run the optimizer again. And now instead of generating a single file, it's going to optimize the different files separately, right? So now notice that for every file, there's a new .mdl asm file generated, right? And if I open one of them, oops. Now you see every line, it is the same original file, but every time MDL has applied an optimization, the lines that it has removed are marked with -mdl, the lines that it has added are marked with +mdl. So in this case, it has optimized CP1 by deck A, and you can just search through all of the optimizations with these codes, right? These MDL codes showing you everything that it has modified, right? So now you have all of the files right there exactly as you had them just optimized, right? So for example, if I open the main, now, of course, the includes are modified to include the optimized files as well, right? But now you have exactly in the same way as you had it originally, just optimized, right? And of course, you can just remove it by, you can just remove all the mdl.asm files to get back to the way we had it. Let me now very quickly show you how can MDL help you analyze your code. MDL can do lots of things to help you analyze code, but let me just show you a couple of them very quickly. All right, so I'm again here in the Xpelunker folder. So I'm just gonna, for example, let's see, I'm just gonna call MDL like this with the main file of Spelunker. And I actually want to see where am I using space? So what is actually using space in Spelunker? So I'm just going to call, whoops, it should be dot. I'm just going to call MDL with a dash dot flag. And this has just generated a file called spelunk.dot, as I just specified here, right? And if you guys have used dot before, dot is just a graph visualization software, right? So now I can for some reason I don't have a dot in my path, but I can just, whoops, I can just call dot, and I want to generate a PNG from this file, and I want to save it as Spelunk as a PNG, right? So there you go. So a PNG just appeared here, and whoops, it went to my other screen. So here it just generated this little graph from the game, where there's a little square for every file. So the root of this graph is the main file. It says the main file uses 32,000 bytes, and the file itself is 1,000. The rest is by files included by it. So for example, it includes this file that has 0 bytes, this other file that uses 314 bytes. So we can just go around and see what is actually using space in our ROM, right? And you just get the tree of everything that gets included into the game. If you don't want to see it like that graphically, because that might be annoying to you, so for example, you can also just call it like this. So I wanna I wanna analyze the same. Whoops, I cannot type like that. But instead of generating a dot file, I just want to generate a text file with exactly the same information, and I want to save it there in Spelunk. This is a TSV file. It's like a tab separated data, and I also want to include binary files. If you don't put this dash plus bin, all the binary files are not included in the analysis. It's only the source file. And there you go. So this TSV file has just been generated here, and here you can see every single file included in the project, the size that it uses, and the total size. So self size is the size used by the file itself. And if that file includes other files, then that is accounted into the total size, right? So you can see here everything that uses space in Spelunker. And of course, Spelunk main.asm, which is the main file, uses the full 32 kilobyte of the ROM, which is what Spelunker uses. All right, so there's MDL can do many more things, but this is just a couple of examples. Okay, so I just showed you 3 different ways in which you can use MDL. You could use MDL as a Z80 code linter. You can use MDL to automatically optimize code, or you can use it to analyze code to help you see where you're using space and many other things that MDL can actually help you with. So the next thing I wanted to talk about is what kind of input can MDL take. But this video is getting a little bit long, so I'm going to stop here. And in the next, I might record a couple of next videos to explain you the type of input that MDL take and how does it optimize code, right? Because you might be thinking, wait a minute, but there's a lot of assemblers out there, right? And the syntax of the different assemblers is not really compatible. So how do I have to write my code so that MDL can actually parse it, right? So MDL can take code from a lot of different assemblers, and I will explain all of those details in the next video. And the final thing is how does MDL optimize code? You might also be thinking that, wait a minute, Santi, but so one of those optimizations that you showed us before as an example is actually quite dangerous, right? If you replace a comparison with 1 with just decreasing the accumulator, that might actually break my code, because I might be counting on the accumulator to actually have the value 1 later on. And sure, so MDL has mechanisms to account for all of that. It tracks all the dependencies and only does optimizations that are actually safe. So I'll explain how all of that works in the next video. But for now, I think this is getting quite long, so I hope you are intrigued by MDL. The project just started, so I'm quite excited about it. But yeah, again, I hope you find it useful and you try to use it. Right now, it's in very early stages, so it's gonna probably break if you try to use it. But if you use it, it breaks, and you report bugs or errors you find, to me, that's the way to make MDL actually more robust and making it work better in the future. So yeah, that's it. Thank you.